Hey everyone, welcome back to another session with OneClass. My name is Bassam, I'm an engineering graduate, and today we're going to be going through some physics problems at the high school and preliminary university level. So let's get started over here. Okay, let me just show you my screen. Okay, so this is question number 1 that we're going to be going through. So the process that we usually do is we go through what the Janine The Tutor answered this question, and then we're going to verify that the solution is correct on the side here with some step-by-step processes and anything we need to figure out this problem. So for the first question, we're asked, explain about gravitational potential energy. So essentially just the concept that we're looking at is gravitational potential energy. So reading on to the junior tutor's answer, the general form of gravitational potential energy is given as this. So there's just the general form when you have two masses attracting one another, and then we have r for the distance between the objects and g for the gravitational constant. So there's just some constant. And then here r is very, very large. Okay. When the distance between objects r becomes less, that means the object is near the Earth gravity at this time. Earth gravity dominates. So when r is very large, that's when we use this equation up here. But when it gets smaller, then the object is near the Earth, then we use this situation. So at this situation, the below formula can be used. So we use the energy is equal to mass times gravity times height. Okay, so here we have mass of the object, g is a constant, so 9.8 meters per second squared, that's just acceleration due to gravity, and then the height of the object off the mass of the Earth. So just to kind of summarize, there's two equations. The first equation, U, so U here stands for gravitational potential energy, is equal to negative the gravitational constant times the mass 1, capital M, and then mass 2, lowercase m. And then we divide this by r, which is the distance between the objects. So r over here. And then I believe the negative sign here is because it will be pointing towards the object that's pulling. So if we had m, a very large distance, r, and then a smaller m, so this is energy. So yeah, the negative energy has to do with whether which object is doing the work on the other object. That's essentially what this is. But essentially, for a very large distance r, you would just have to use this equation. And then the other equation that we talked about is U equal mgh. And usually for more complex problems, you'll probably use this formula a lot more. This formula up here, you end up just plugging in whatever values you're given. So you probably have mass 1, 2, you have the constant in r. So really it's more plugging in. This formula is when you have lots of different energies interacting, this one you use a lot more for representing potential energy. So I believe there's a example down here. We'll run through this. So calculate the gravitational potential energy of a body of mass 10 kilograms. So we have m equals 10 kilograms and is 20 meters above the ground. So these are in the correct SI units, kilograms and mass, so we don't have to do anything there. H is 20 meters, so I'll put the units. And then we know g is 9.8 meters per second squared. That's just acceleration due to gravity. So here we just plug in these values, 10, 9.8, and h is 20. And this will give us, let me just plug into my calculator. Okay, so we have 10 times 9.8 times 20. And then we have 1960. So that's 1960 joules. So looking at the calculated answer by the junior tutor, so yes, this is correct. Another way to think about this, we know 9.8 is pretty close to 10, so just kind of a mental double check. If we do 20 times 10 times 10, we know that's about 2,000. This number is a little less, so that kind of makes sense. So this is the correct answer for this example. So we'll mark this answer as correct. So correct answer. Great job.